Okay, here we've got two forces acting simultaneously on some object. It could be a mass. Imagine there's a mass right here. One of the forces is pointed upwards to the left at 105 newtons, and the other force is to the upper right at 267 newtons. Now the angle in between these two forces happens to be 113 degrees, and we're trying to figure out what the magnitude, so I don't care about direction, of the third force, which we'll just call F3. What is the magnitude of that third force so that the thing's in translational equilibrium? Now you have to know that translational equilibrium simply means that the object is not accelerating, so it means your net force is zero. So we're looking for a third force so that when you add up all three of them, F1 plus F2 plus F3, they all add to zero. But we have to add them tip to tail. Now, right now my diagram is showing F1 and F2, they're not tip to tail, we're not adding them together yet, they're just showing you how they're acting on the mass. So I can manipulate the diagram quite quickly. So I'll just grab the one mass, F1, and we'll slide it down like that. So it's acting along the same direction, but now I've got a diagram that's tip to tail. So here I've got F1, let me just move my F1 label down. So there's F1 down here. Added tip to tail to F2 should give me a value for F3 if I finish the diagram. So F3, our unknown vector, will start at the tip of F2 and finish the diagram back to the starting position so that there's no gap. So F3 will look like this. We're trying to figure out what F3 is. What is this value? Now we need some angles as usual. Don't forget we had this 113 degree angle that was along the direction of our original F1. So if that's 113 degrees, then this angle right in here, because this line is 180 degrees in total, will just be 180 minus 113. So 180 degrees minus 113 degrees gives me 67 degrees. This little angle right in here is 67 degrees. So we know one of the sides is 267. The other side is 105. We know the angle in between those two sides, and we're trying to find the third side. So because I know an angle in between two sides, and it's not a 90-degree triangle, I'm going to use the cosine law. Now, just to remind you, the cosine law starts like Pythagoras, but then makes that adjustment for the fact that it's not a 90-degree triangle. Now, once again, all you have to remember is that A and B are on either side of the known angle. Doesn't matter which one's A and which one's B. There's no longest side in the cosine law, so we're good to go. So let's just say A is 105. Let's make B 267. And then the angle in between A and B, we've determined to be 67 degrees. Now we're calling C F3. So in other words, F3 squared is all of this stuff to the right. And when I solve this for F3 by taking a square root, when all is said and done, I get 246 newtons.